Hey everyone, and thanks for clicking on my video. Today I bring you this little tiny tracked robot. I'm going to start off here with just the testing and the practical side, and I'm going to go into the more theoretical side later, and the timestamps for that will be down in the description if you want to skip ahead to the build or electrical parts of the video. After designing and printing most of the parts and throwing everything together, I loaded up the basic program and I tossed it on the floor right beside my computer, and the cat found it rather interesting. Now before I get too far, I'm going to mention I did have some issues with pins 3 and 4 on the board I'm using. Those are the USB pins, and I seem to have some funny interactions with the motor controller pins and the sensor pins, so I had to play around and kind of figure out what worked here and there, and the final wiring I give is what worked for me. So I let this little guy roam around my house for a while, confusing the cats, and after a little bit I noticed some issues. First issue I'm going to mention is the infrared sensor can be confused by sunlight and non-reflective surfaces, which ends with the robot just driving into it and the tracks and everything being light enough, it just kind of slips. Eventually it might work its way off some sort of surface, but sometimes it gets stuck. I noticed the beginnings of a few other issues, but I'll talk about those later. With the initial success, I designed and printed off a top cover that fit a little better than my initial design, and I added a camera mount for this little SQ camera. I think that's what they are. Little cube cameras, cheap on eBay. I thought it'd be interesting to see the perspective that the robot sees, from that low to the ground. After being pretty satisfied with how it was working, I decided to leave it to its own devices and see what happened. After a few minutes of leaving it to its own devices, I went to check on it and found it had basically gotten stuck in this little alcove of stuff over here. And the reason for this is it seems to be, the random number generator isn't so random. I knew that was a thing already. And it seems to generate a pattern. And if the pattern lines up with the area it's in well enough, it won't let it out. And it basically just keeps driving in circles. This ended up happening a few places in my house. My house isn't really the most uncluttered, which makes it a good test for this sort of robot, I guess. But it seemed to be a constant issue. The other issue is, again, that it seems to get caught on something and doesn't want to get off of it, and the sensor doesn't notice it. Instead of solving that problem right away, I just kind of sat on it and thought about it for a bit. While doing that, I decided to put this little guy to work, and I put a little Swiffer pad on the back so it could suck up some of the dust that's kicking around my house. Believe me, between the cats and the people in my house, it's very difficult to keep up with everything. Maybe an army of these little guys could do it for me. After sleeping on a few of the issues I've had, I come up with a few modifications to the program that should hopefully solve our problems. The first solution being, once the sensor is triggered more than 6 or 7 times in a row, it runs a little bit of a canned movement cycle, and this is to hopefully get it unstuck from any circles and kind of reset the random number generator. The second solution you can see right here starts right after the end of the first can cycle, and how this is supposed to work is after a certain number of trips around the main program loop, it runs another randomized canned cycle that should get it unstuck from anything that it happens to be stuck on that's not triggering the sensor. With the program uploaded, it's time to give it another test. So I started it up, left it alone, and I'll come back in a little bit and see what happens. I come back to find that it's stuck on this cord. Now, this sort of cord seems to be this little robot's worst enemy. It climbs up on it and then gets stuck. And it's high-centered. No matter what I do, no matter what the controls do, no matter what it tries to do, it will never really work itself off. Now, here we see my modified program in action. You can see here that it runs into the hose here for a couple minutes, and then it decides it's going to turn and back away from it, and it seems to head off in the other direction. And by the time this video is being posted, you're up to date as far as I am. After this, I go into the more technical details, but I'm going to leave you with some wandering music and a few minutes of footage of it just wandering around. Feel free to skip ahead to the technical details. So we'll start with the simple program. Now in this program, you can see here at the top, you got the integers, all your pin modes, and I start here with everything set exactly where I want it to start off with. And then we get into the void loop. We start off with a random number generated between 1000 and 4000, and then it reads the sensor value integer. The next group of digital writes just makes the robot go forward. Now to note, I wired one of the motors backwards from the other one, so normally this would be reverse for the one side and forward for the other, but I had to play with the wires a bit. After that, we get into the if statement, and it's pretty simple. If the sensor value is low, now that trigger is default high. When the sensor value goes low, it triggers the turning mode. It turns for the random number generated time delay and then starts back at the top of the loop again. And on to the more complicated program. Just a note, I'm not an expert programmer or anything. I'm just basically doing this by trial and error. Now I had to move some of the if statements around to make this function the way I wanted, but it's more or less the same. The main part of the program makes the robot drive forward, and then when triggered with something in front of it, it makes a right or left hand turn or counterclockwise turn motion for a random moment of time. However, in this program, I added two counters. One integer named counter is added to every time the sensor is triggered, and the other integer named trip adds 1 to the integer every time it makes a full circle around the loop or back to the top of the loop. The idea being is if it goes straight long enough with no interference or anything happening, it makes some erratic movements that will hopefully get it away from anything that it's stuck to. And if it's stuck within a little bit of a triangle or a couple objects, the more particular motion after 6 turns or triggers of the sensor should help to eliminate the pattern altogether. Starting with the power supply, I'm using a 3.7 volt lithium ion battery. You could use whatever you want to kind of run this system, whatever fits in there. This is just what works for me. To make this work properly, everything needs the 5 volts without messing with any onboard parts. So I use this little USB converter. Now this will run down off of a AAA battery, but I wouldn't use it for that. I don't think it'll make enough amperage to drive this. Once I have the 5 volts, everything else is just hooked in parallel, and we move on to the signal wiring. Controlling the version in the video, I'm using this AT-Tiny DigiSpark module. As I mentioned before, I had some issues with the pins that run parallel with the USB port, and I ended up having to not use one of them, and that avoids me having reverse on both motors. For future purposes, I intend to work with a Arduino Nano or maybe a Pro Micro or some other microcontroller. If you have any good suggestions for this, let me know, eh? Since there's not a lot of connections here, I don't really have to explain too much. Everything should line up with the program given and the picture in front of you. But I will note that I do have the gray wire set up as the forward pin for that motor, and that's just because, again, I have the motor wired backwards to what it should be, and I didn't feel like resoldering it, so just jumped the pin on a different part of the board, that's all. I really don't know what else I need to explain to this. If you do have any questions, throw them in the comments and I'll do my best to answer them for you. Otherwise, we're going to keep going and move on to the next stage. And here's how it looks with the cover off. And you can see I'm using the pin headers. You could just solder the pins. I wouldn't have recommended that just for prototyping, but now that I got it sorted out, I could make a unit that's completely soldered together. On to assembly. I start by soldering leads to both motors. Once both motors have leads on them, I installed them into the frame. These motors take a 1.6 by 0.5 millimeter screw, if I'm not mistaken, which is rather hard to find. Surprisingly, I managed to find some out of a toy helicopter that seemed to fit. I don't know if they're the right ones, but they do for this. Now to mount the AT-Tiny controller board. This just takes very short 3mm screws, bolted through the anchor holes on the board. For a motor controller, I'm using an MX1508, which I'm pretty sure is just a little H-bridge on an IC on a board, but it works nicely for this. It has speed control, but this thing isn't going fast enough, I don't really need to use that. However, if you wanted, the speed control is used with pulse width modulation. Jeez, I can't talk today. I soldered the motor wires to the board and attached the wires that'll connect to the DigiSpark controller. This board just mounts on a little pod and a little shelf I made in the design. The hole is tapped M2, which I'm pretty sure doesn't print, so you can just use a little wood screw or plastic screw for this, which is probably much easier to source. For the power supply, I'm using this little USB power supply. However, I don't want the port, and I'm going to cut the board a little bit shorter to fit it in there. You can buy them already set up like this without the port sorted on. However, this is something I realized I needed halfway through the project and didn't want to wait. So I cut up something I already had. With the rest of the power wires hooked up, all terminated to the main power board, I just plug in all the signal wires. And again, I had issues with this, and the final drawing I'm going to show you here lines up with the program I'm giving you as well. However, you may have to switch the gray wire for the white wire depending on how you end up with the motors. And that's more or less it from here. The sensor just bolts to the top panel and everything just goes on top of that. And once you get everything all on, you can put the top cover on top of that. Oh, and for mounting that little power supply, I didn't really make anything to mount it on. I just kind of stuck it in there and used a little dab of hot glue or super glue to hold it in place. It can just really rattle around in there. It's not like it's doing that much anyways. And for the last little bit, the wheels and track, the idlers are just held on by M4 bolts, and the drive wheels push on and are held on by M3 set screws. Now the tracks are printed TPU, they should stretch over enough to get them on. Now the battery cover just snaps in and can be held in with one screw if it becomes loose. And that's about all I have for now. However, future considerations, I was considering some sort of internet controlled board and a bunch of these robots in a swarm configuration, either cleaning or plowing maybe, or some sort of application. I don't really have anything nailed down yet, I'm just kind of brainstorming. If anyone has any suggestions that would make that a little bit easier, or what kind of hardware or software to use for that, let me know down in the comments. If you want to hear more from me, click subscribe and ring that little bell. And if you really enjoyed this, click that like button. It really helps the channel out. Thank you guys for watching, and have yourselves a good one.